Hello guys, how are you? Today I'm going to explain the first section of the chapter, which is Introduction to Chemical Bonding. First of all, what we mean by chemical bond. It is a mutual electrical attraction between the nuclei and the valence electron of different atom that binds the atoms together. So here we are talking about attraction between nucleus of an atom with the valence electrons of another atom, as we said before. Now, how could atoms form chemical bond? As explained before, atoms could lose or share electron, and actually the nature of the atom will determine the type of the bond that will be formed. So, first we have ionic bonding, electrical attraction between cations and anions. And the covalent bond is a ring of electron pairs between two atoms. If we are talking about an atom here with the valence electron, and as we said before, valence electrons are electrons located at the outer shell, with another atom here. The nucleus is positively charged. When the nucleus of this atom attracts the electrons of the outer shell in another atom, this is the forming of, or the nature of, bond. And the other nucleus here will attract the electrons of the other atom to form the bond with it. So all of it is a type of attraction. And as we said, we're going to talk about two types of chemical bonding. First one is ionic bond, and the second one is covalent bond. Ionic bond. It is a result of attraction between cations and anions. So for example, if we have Na plus, this is a cation, and we have Cl minus, which is a cation. The attraction between electrostatic attraction between negative charge here with the positive charge here will form ionic bond. And we know that sodium will be formed because Na atom loses an electron out to form Na plus, while Cl minus, the chlorine atom, will gain this electron to form Cl minus. So the same electron here that lost from Na will go to chlorine. This is why chlorine become after that Cl minus. After this process, electrostatic attraction between Cl minus and Na plus will form what we called ionic bond. While in other type of compounds, like for example H2O, which is water, oxygen contain 6 valence electron, and hydrogen contains only 1 valence electron. Now, because hydrogen is not ready to totally lose the electron here, it will share the electron with oxygen and form a shared orbital between both of atoms. and the electrons here will behave as if they belong to both atoms at the same time. So here we have type of sharing. So hydrogen will be stable and oxygen will react with another hydrogen atom and share other electron with another hydrogen atom. So finally we will have OH. So this is a covalent bond. Main differences that you have to know between ionic and covalent bond, that in ionic bond we have losing and gaining of electrons, while in the covalent bond we have sharing of electrons. In the ionic bond, the electrons completely leave the orbitals of the atom, but here the electrons are located in shared or overlapped orbitals. I hope guys you write these notes at your copy book to study it later. This is the main difference between ionic and covalent. And how can we determine if the bond that will be formed is ionic or covalent? This is actually depends on the electronegativity difference. Now, this point here we'll talk about the stable bond. 3, 1.7 in most books. Now, if the electronegativity difference between two different atoms is less than 0.3, so we will have non-polar covalent bond. But if the electronegativity difference is over 0.3 but below 1.7, then we will have polar covalent bond. While if the difference is over 1.7, then we will have ionic bond. So for example, if we have the OCl bond. Now electronegativity for chlorine is 3, while for oxygen it is 3.5. Now the difference here, electronegativity difference, is 3.5 minus 3, which is 0.5. So 0.5 is located in the range between 0.3 and 1.7. So we will have polar covalent bond. So the bond here is polar covalent bond. Why? For example, if we have NaCl, as we know, chlorine electronegativity is 3, and for sodium 0.9. Now the difference here is 3 minus 0.9, which is 2.1. It is located at the ionic bond region, So NaCl will form ionic bond. And it is just simple like that. So the difference in electronegativity between both atoms will actually be the main factor that will determine the nature of the bond. And here I want you to know that in many cases, we are not talking here about specific and fixed numbers, many factors that affect the bond, depending on the size of the atom, how many valence electrons we have, what type of orbital is located, what type of the valence orbitals are in each atom, and the electronegativity differences is not always very clear for us. So just take it as a general knowledge. This is another example for electronegativity difference between hydrogen and cesium and the chlorine. As you can see here, we could have polar covalent bond between hydrogen and sulfur because the difference is 0.4, and we have ionic bond between hydrogen and cesium because the difference is 1.8, and we have polar covalent bond again between hydrogen and the chlorine because the difference is 0.5. Here in this shape, we have a type of nonpolar covalent bond and polar covalent bond. And the difference between them, that if we have a difference in electronegativity, but this difference is not more than 1.7, so we will have a covalent bond. And it will be polar because this difference will do the following. If we have hydrogen, for example, here, with electronegativity 2.1, and oxygen with electronegativity 3.5. Now the difference here is 3.5 minus 2.1 equals 1.4. So we have polar covalent bond. But because electronegativity of oxygen is higher than electronegativity of hydrogen, it will be able to pull the electrons closer to oxygen atom. So the electron could be located here, closer to oxygen than hydrogen. And because electrons are closer to oxygen, so oxygen will have a partially negative charge, while hydrogen will be partially positive charge. Partial negative and partial positive. We are not talking about a complete negative and complete positive. We're just talking about partial negative and partial positive charge. This is the meaning of polarity. So polarity means that we have two poles for the for the compound. One is positive and the other one is negative. Another example, if we are talking about chlorine, Cl2, we have chlorine with chlorine. Here, as you can see, we have two similar atoms. So electronegativity will be same for both atoms. So the electrons, the ability of each atom to pull the electrons closer to it will be the same. So the electrons will be shared in the middle between both atoms. So at this case, we don't have poles. We have no net forces because both forces will cancel each other. This is why here we have non-polar covalent bond. So we can say simply polarity means net force. Keep it this simple and you will get it very easy, and it will be very easy for you. Don't expand the concepts for now. We're going to study this more and more in next stages and next chapters. Thank you and be safe.